The Termination Insensitive Amplifier was popularized by Wes W7ZOI and Bob K3NHI. The amplifier is a basic gain block with 15 to 20 dB of gain and with the useful characteristic that its input impedance is not affected by load. Termination insensitive amplifiers were widely used in the BiTx transceivers, the BiTx 40 and the micro BiTx. I even made up a scratch-built BiTx for 20 and 40 meters, and it worked pretty well. The TIA was used in the bidirectional configuration in the BiTx. So one TIA was used in the receive direction, and an identical TIA was used in the transmit direction. This made the architecture symmetrical, that is, by just flipping power between the transmit amplifiers and the receive amplifiers, you could have the signal travel in either direction. Between, for instance, filters or mixers between the TIA blocks. Because the TIA block was fixed gain, the uBiTx had no AGC. But one of the great things about this project was that they were hackable, completely open-sourced hardware and software. Soon there were so many AGC hacks and circuits, it was a bit baffling to know which one to try. Heaven forbid there was even one by VK3HN. Actually, it was my implementation of an idea from Peter VK3YE. Most of these hacks used rectified audio to in turn damp down the audio stage gain in a kind of a crude feedback mechanism. This one by Don November Delta 6 Tango rectified some audio and then used it to switch a MOSFET across the receiver front end to blank the RF stage, kind of like a noise blanker. All of these AGC hacks worked to a degree, but many of them suffered from limited gain range. And that's because they were not able to operate on the part of the receiver that contributed the most gain. That's the IF stage. In short, the most effective AGCs reduce the gain in the IF. And because the TIA gain was fixed, that was not possible. So I was particularly interested when I saw a post from George, VK4AMG, back in March 2021, where George described a simple modification to the TIA in the uBiTx. He cleverly replaced the emitter degeneration resistor with an NPN transistor's collector-emitter junction. Effectively unbiased and unpowered, this creates a low impedance which varies with the voltage on the base, creating a simple AGC mechanism. George reported 34 dB of AGC swing for 5 volts difference on the base of the emitter degeneration transistor. And he built up a simple 2-stage AGC amplifier that took audio from the volume control, rectified it, and produced that 0 to 5 volt AGC line. I built up 2 of these AGC controlled gain blocks with a simple crystal filter in the middle. I put it on the bench and did quite a bit of testing, and I was able to mostly reproduce George's results. I then built the IF strip into a receiver I was working on and demonstrated the AGC action. I decided to send an email to Bill and Pete, and while they were both encouraging, Bill wasn't so sure. Bill pointed out that if you changed the emitter degeneration resistor, the gain would be affected, but there might be other side effects as well. We read that the feedback resistor and the emitter degeneration resistor, in combination with the load, set the input at 50 ohms. These parts also establish the gain. So my circuit was effectively altering the emitter degeneration resistor RD. Sure, it was changing the gain, but it was probably also changing other things as well, in particular the 50 ohm input impedance. So this circuit modification is certainly capable. I wrapped up my blog post with an honest assessment under AGC control, but it's almost certainly swinging the input impedance around at the same time. So by this stage, I'd made a video, posted on the blog, a few people had shared some comments, and I thought this was just about it. Little did I know that Bill N2CQR had emailed the man himself, Wes, W7ZOI, and that Wes had responded saying he'd take a look at it. A couple of months later, and Wes had published a new paper on an AGC-controlled TIA, in which he inserted a gain control stage, basically the same as the gain control stages in the hybrid Cascode IF strip, into the middle of the TIA after the common emitter amplifier stage and before the two emitter followers. This had to be prototyped. Here's the new paper on the W7ZOI website, August 29, 2021, in which Wes goes through and revises the theory of the TIA and adds a new gain section or gain-controlled section in the middle. I redrew the schematic and started laying out a printed circuit board. But before getting too far with an offshore PCB fabrication, I prototyped it on a homemade printed circuit board with mostly surface mount components. Looking at the amplifier's input and output, the input is the purple trace, the output is the yellow trace, and this is what you see when you sweep with a nano VNA across, in this case, 3 MHz to 21 MHz. Both of the scope channels are set to 50 millivolts per division, so the same vertical gain or amplitude gain. So we're looking at a amplifier gain of around about 10 or 20 dB. Between the nano VNA and the amplifier input, we've got a 10 dB pad, and there is no attenuation on the output. The amplifier is running at maximum gain and off a 12 volt supply. And we've landed on 12 megahertz here, and the gain of the stage is the difference between channel 0 and channel 1, so the difference between minus 22 dB and minus 4, so around about 18 dB of gain there. Don't forget the 10 dB pad, so 28 dB in total. So let's take it down to 9 megahertz, round about there. So 20 plus 10, about 30 dB of gain. And the input impedance is 50.8 ohms. So now if I wind back the AGC voltage level, you can see that the gain quickly drops down to below unity and then right back up again. So go and check out Wes's new paper on an AGC controlled TIA. It's over at W7ZOI.net. I hope you've enjoyed this two-part series on adding AGC to the Termination Insensitive Amplifier. Hopefully others will experiment with this circuit block and report their results as well. As for me, well, it finally looks like these VK3 lockdowns are at an end. So with summer approaching, there'll be time to get back into the mountains, into the hills. Thanks for watching. Please like and subscribe, and see you next time.